review. Hopefully you're ready to go. Maybe we'll just talk a little bit as it's starting to warm up. First one says, determine if it's possible to form the following shapes by rotating a two-dimensional shape around the y-axis. If so, state the shape needed to do so. A sphere. The answer to that would be a yes. You could either do it with a semicircle, or you could even do it with just a circle. Either one of those would work. Okay? Let me zoom in a little bit here. Perfect. So, how about a right prism? Well, the only problem is as you rotate things around an axis, as you rotate, it's going to create circular things. There's no way to make a right prism. A cylinder, yes, you would need some kind of rectangle. And as you rotate it, then it becomes a cylinder. So it says you have a cylinder that's full of water, measures 10 inches in diameter, 7 inches in height. You place a solid cube that has a side length of 5 inches into the cylinder. How much water in cubic inches will flow out? Well, let's first find the volume of the cylinder. To find the volume of the cylinder, area of the base, which will be pi, radius, since the diameter is 10, the radius is 5, squared times its height. So this is the total volume of the cylinder right now. 7 times 25. So 7 times 25 happens to be 175 pi. And that would be in cubic inches. Now we're going to take a solid cube and place it down inside. If that's going to happen, then whatever volume is in that cube will have to come out of the cylinder. So let's find the volume of the cube. To find the volume of the cube, I take the side length 5 times 5 times 5, because all three sides will be the same, which is 125. So therefore then it says how much water in cubic inches will flow out of the cylinder, and how much will be left. So the flow out will be 175 pi minus 125. So if I do it on my calculator, okay, I would take 175 pi minus 125, and I get approximately on the flow out 424.779 cubic inches. That's what's flowing out. How much is left in is I'd have to take, or actually, sorry, I lied. Ha, that's a full class ticket. This is how much is left in. This is how much is left in. Okay? The flow out would be this number right here, 125 cubic inches. That's what's going to flow out. Then subtract it, and that's how much is left. Okay? Perfect. There we go. Draw a cross-section that can be rotated around the x-axis to create the given solid. And since they put the x-axis clear up here, I'll just draw the bottom part of this. It may look something kind of like this. I'm not, great at drawing these things. So there it is. That would be rotating around the x-axis. And if you rotate it, then you get something that looks something similar to that. Give me just 1 second, all right? So here we go. Here's a pill-shaped like cylinder with 2 half spheres on either end. It says find the volume and then exact and approximate for the pill. So if I look at the, sorry, let me move it up here. So if I look at the volume of this is a hemisphere and this hemisphere. So if I put them together, that gives me a sphere. And then I have a cylinder. So the volume of the sphere is going to be 4/3 pi times the radius. In this case, it says the diameter is 4, so that means the radius would be 2 cubed. That's going to be the volume of the sphere. Volume of the cylinder is going to be the area of the base, so pi times radius squared times the height, which is 5. So in this case, I get 8 times 4, which is 32, pi over 3, and that's going to be in millimeters cubed. Here I get 4 times 5, which is 20, pi millimeters cubed. So I need to add those two together. Adding them together, I could get a common denominator of 3, which would mean I need to multiply the top and the bottom by 3. 3 times 20 is 60. 60 plus 32 is 92. So exact volume would be 92 pi over 3 millimeters cubed. To find the approximate volume, I would take my calculator. I'd take 92 times pi divided by 3, and I would get approximately 96.342 millimeters cubed. Okay, do the next page here in just a second. Hey, brother, what's up, Jamie?
Alright.
You're like, all right.
Yeah, because I have a lot of questions that
Sure.
I just couldn't figure out.
Sure.
And I need a lot of help because it seems like I didn't understand as much as I thought.
Okay, well, good. I'm glad you're coming in.
Yeah.
So let's talk. Why don't you go ahead? Why don't you just bring us a desk? Just bring a desk up. You're all right. Just bring a desk up. Kind of give us just a little more workspace, right?
Yeah.
Just a little more workspace. Do you have a pencil?
A pencil?
Or do you need a pencil? Or
I have one.
you have one? Bring it over.
It's actually in my pocket.
It's in your pocket. That's sweet. Okay.
Okay, so I have I don't really understand where this comes from.
Okay.
The where you get those answers.
The horizontal or the limit?
The limit. And
The limit part.
for question 12,
Uh-huh.
so I tried to find the horizontal. Plugged this in, didn't work. I moved on to the next step and tried to factor it, and gave me some weird number that I can't really.
Okay. So let's first of all, as x approach, are we approaching infinity or negative infinity?
We're just staying at 0.
Okay, so we're doing finite.
Yes.
So we're not going to compare. So the kind of the 4-step process. Step 1 is gone.
Mhm.
Step 2, then, do you remember what step 2 was?
Factor.
Factor and divide if possible, right?
Yeah.
Is there anything we can factor out?
Yes, the x.
Good. So factor out the x for me.
Factor out.
Mhm.
And I didn't quite memorize the whole thing yet.
That's okay. You're all right. That's why we're kind of walking through,
Yes.
right?
Okay. And then x 2x squared is 2. Okay.
Then where do we go? Do you remember where we went from there? Oh, okay. So then from here, now we divide.
Divide.
So what are you going to do?
Turn this into x over x and then bring
That's
it to
just,
1.
Good. So it's just this. So write that.
Okay.
Negative. Okay. Yes, I got it. Now we're going to find the left and the right-hand limit. So in other words, we're going to let x approach 0 from the left and the right-hand side. So let's start it from the left-hand side. So if I let something get really close to 0, if I let x get really, really close to 0,
it would just be
what's 0? Something really close to 0 squared going to go to?
0. This would be 6 and then 2. Oh, then would be 3 then. Because
So what's 6 divided by 2?
Huh?
So like you said, 6 over 2.
6 over 2.
Which is?
3, which is where you find the limit. Okay.
Right. And if we look at it from coming from the right side, so just a little bit bigger than 0, something a little bit bigger than 0 squared is still going to be?
Say that again?
Something a little bit bigger than 0 squared is still going to be really close to
0.
And 0 times negative 4 is
0.
something really close to 0 plus 0 is going to be 0.
0.
Add 6, you get
6.
same thing down here,
And
and that's where we get the 3.
okay.
So that's where we get the limit from. Now remember, notation is kind of really key, right? And I know that you're like, yeah, but I don't want to, but you got to.
Okay.
So just remember that, okay? So even though you don't want to, you got to.
Is this exactly how you're supposed to write the answers?
So, yes.
Okay.
So the way you see here, or you could have written, so as you started it, you had the limit, right?
Yes.
As x approaches 0, and you had this whole big thing. I think it was negative 4x cubed, is that what it was?
4x.
Plus x squared plus 6x over 2x squared plus 3x. So this is x cubed plus 3x squared plus
2x equal.
right, equals. Then you started doing some work, right?
Okay.
Equals, and then the first thing you did was you
Well,
factored,
I factored out.
right?
And then
So then it
divided.
should look something like this. I just want to make sure, I want you to get a 5 on the test, or as high as you can, Jamie. Does that make sense what I'm saying?
Yeah.
And I'd hate for you to miss certain points just because your notation wasn't where it needed to be. Like these are easy points that you don't want to ever miss out on. Equals, and then in this point in time, 3.
It also helps you become more organized, right?
It does. It does. Because like, you see how this kind of flows? So we're right here. Now, do you want to look at another one?
Another one?
Another one that you had issues or problems with that you want to talk about?
Yeah. So
Was it just mostly finding the limits that were the hard part?
it's just
Or was the horizontal asymptotes the hard part?
sometimes they're you throw in a question and sometimes something changes a little bit about it and I just can't figure it out.
It's so true. It's so true.
The way you have to solve it kind of changes and then
Just a little bit. Again, still just think through those processes. So, which one do you want to work on?
So ones that don't have one.
Okay, you want to look at 16 then?
Huh?
So 16? Is that what you're saying?
Let's do 16.
Sure.
Because
Sure.
I'm just picking whatever
Yeah.
at this point.
Sure. So, first step, determine if you're going where.
If you're going to infinity or negative
Correct.
infinity.
So are we?
Yes, therefore it is a horizontal asymptote.
Well, it's not necessarily that there's a horizontal asymptote, but so we are going to infinity or negative infinity. So the very first thing we do then is compare terms that add.
The terms that add?
Terms that add. So,
oh, as
so
in like
up top,
ones that are
so up top, yep, so up top you have this term, you have this term. Which one's going to get bigger more quickly or the fastest? So that's the part that's going to matter the most, right?
Yes.
So we have the limit as x approaches infinity of x cubed plus 10x squared. And just always get in the habit of writing this out, man.
Okay.
Equals. And then down here we'll write equals. And so what did we say we're going to do? We're going to compare these two.
Pick the other one, and that one won't really matter too much.
Correct. So it's x cubed. Then I compare
yeah, that's where
those three.
And I picked 4x squared.
Good.
I didn't do that. I thought it was just the biggest one, and then if it doesn't work out, it's probably 0 or something.
It's okay. So now that we're here, we've compared, we go to step 2, which is to factor and
divide.
Correct. So we factor and divide.
So you try getting rid of this x squared.
So can you factor anything out of both of these? And you said what?
X squared.
Correct. So it'd be x squared over x squared times x over
4.
Correct. This is going to become
Cancel out.
1. Oh, yeah, don't say cancel. Divide
Sorry,
by 1.
cancel.
It's alright, divide by 1.
It's like hardware.
So then we get x over 4, and again, now we're to the next check, which is, okay, I'm going to actually let it get close to infinity. And it had to be from the left, because it can't be from the right. As I let x get really close to infinity from the left, what's something infinitely large divided by 4 going to get close to?
Pretty much infinity. If we
That's
keep
correct.
letting it go.
That's correct. Which means that the limit
Does not
does not
exist.
exist because this is not a number or a value.
Okay. It's
It's okay. Let's work. I'm gonna have you work some problems.
work some problems.
Yeah. So
Okay.
just do one that you want to do.
One that looks different.
Sure.
I'm gonna try looking for. Let's try.
And I'm not gonna talk. I'm gonna let you talk. I may ask questions, but I'm gonna have you talk.
Okay. Let's do number 14. Then.
Sure. Okay, talk it through here.